Hello, everyone, and welcome to our 10th week in our course on drugs and behavior. So last week we looked at alcohol, which is obviously a very common drug, very commonly abused. Uh, this week we'll look at tobacco. And tobacco is obviously another common drug. It's a natural product, so it has a long history. And it also carries with it a high risk of dependence and a lot of negative consequences, just like alcohol does. Tobaccos tend to be more in the long term, but we'll get to that when we talk about the effects of tobacco. So, to begin, we're going to look at tobacco this week, and of course, because it's a natural product, it has this long history that we'll go over. We'll also talk about the consequences of use. So, both the short-term effects on the body and the brain, and the long-term. And of course, many of us are familiar with the long-term consequences of tobacco use, at least some of them. Turns out there are a large number of them. We'll go over them. And we'll also go over nicotine dependence, nicotine being the primary ingredient, the psychoactive ingredient in tobacco. So, why is tobacco addictive? What are the consequences of dependence? And what are the options for treatment? So in this session in particular, we'll work more on the historical end, as well as what the different forms of tobacco are. There are different ways of using tobacco, and they've varied throughout history as to which one's more popular. But it does determine how nicotine is absorbed into the body, and it does determine some of the long-term health consequences in terms of what form of tobacco you're using. Different forms have different consequences for long-term health. So we'll also talk about the brain. How does nicotine affect the brain and why? Okay, before we get on to our discussion of tobacco, a little bit of housekeeping. So there was an announcement that went out this last week about paper number 2. So that's going to be due in a few weeks. Obviously, we just had the midterm, so you have some time. But keep that in mind. We have a few weeks until paper number 2 is due. It will be similar to paper number 1. You're going to have to do research. You have to do a little bit more research, a couple more sources, so check the requirements on that. Instead of focusing on a particular drug, this is going to be what I call an argument paper. So you'll be focusing on a controversial issue instead of a particular drug. So you'll be making an argument, you'll be taking a position, and defending that position with evidence. So you'll talk about the history of the issue, what evidence supports your stance on the issue, and you'll also need to talk about the opposing stance. What's the other side of that issue? So you'll need to talk about it and explain what the evidence is for that side, but also explain why that side is perhaps not as convincing or why that's not the side that you've taken. So for all of these controversial issues, there are arguments for either one, but you need to make it clear why you've chosen the side that you've chosen. A word about your research. So people were, in general, pretty good about doing research on paper number 1. One word of caution is to be careful with your citations. And what I mean by that is not so much the format, although following APA format in the bibliography is important, but remember what the difference is between a paraphrase and a direct quote. So a direct quote, you're using the author's words, and if you're using the author's words, that is the author of the source that you're citing, you need to put that in quotation marks. You need to indicate that those are the author's words and not yours. And then, of course, put the citation at the end or refer to the source itself, saying, Smith et al. Say that, and then the direct quote. For a paraphrase, you still need to cite the work at the end of the sentence. But a paraphrase is your words. You're summarizing the contents of the article with your words. And so you still need to cite where that came from. But you don't need direct quotes. You don't need quotation marks because it's not a direct quote. It's a paraphrase. And don't do what we call mosaic quoting, which is where you change every fourth word so that it's not quite the same quote. Don't do that. That's sort of neither here nor there. That's just a practice to avoid in general. So don't do that. Be sure to cite all the sources that are in your bibliography, but also anything that you directly quote or paraphrase should also be in your bibliography. So there should be a good match between what's in the bibliography and the papers, the sources that are cited in your paper itself. So just a quick word about that. Think about that while you're writing your paper and you're writing your bibliography, just to be careful with your citations. Okay, that is it for the announcement on paper number 2. We'll keep the same discussion groups for this week on tobacco. I will rotate them for next time, so we'll change the groups again. Okay, so moving on to tobacco. Tobacco is a plant. It's a natural product. And the species that's most commonly used is Nicotiana tabacum. So that is a large-leaf plant. There's also Nicotiana rustica, and that distinction has some historical importance. We'll mention it briefly. But those are the plants that are referred to as tobacco, that are smoked or used for their nicotine content. So they're native to the New World, to the Americas. Tobacco is actually native to Central and South America, rustica to North America, and so the original European colonists grew the varieties that were native to those areas, but tobacco is in most ways a better product in terms of nicotine content, ease of cultivation, things like this. But it's native to the New World, so Native Americans had extensive experience with tobacco plant, and Europeans didn't. It was new to Europeans when they first started arriving in the late 15th century. But it was used by Native Americans, not recreationally, so much as medicinally and for religious ceremonies, and I'll talk more about that in a moment. But of course, Europeans did eventually start arriving to the New World, to the Americas, and they discovered fairly quickly that tobacco was a potential economic product. There were many in the New World, and agricultural products were, of course, emphasized by European colonies of all the nations that were colonized in the Americas. But of course, this tobacco is one of the linchpins that set up the economic environment of the colonial era. Rum, sugarcane, and rum, which is derived from it, in addition to cotton, these were all important in the New World. Rum, sugarcane, molasses were made in the sort of in the tropics in the Caribbean, but tobacco and cotton, for example, were made in great quantities, grown in great quantities, in the British colonies. And those two species of tobacco, at first, the Spanish had exclusive access to Nicotiana tabacum. But later on, the British eventually got seeds for that species and started growing it, and after a while, that was a huge cash crop for the British colonies in North America. And of course, this was an economic product, so it would be exported to Europe, where it was consumed. Europe, of course, had the industrial capacity to make manufactured goods, so those goods would be transferred back to the New World. And of course, there was also the unfortunate aspect of all this, which was the trade in African slaves. That these were individuals that were captured by European powers and transferred forcibly to the Caribbean, to North America, to grow these agricultural products. Again, this was an economic system. The moral implications weren't really considered for quite some time, and even then, if your livelihood depended on it, those individuals tended to ignore the moral aspect of this sort of trade triangle. And of course, later on, it was discovered that tobacco was actually harmful itself, so it was another moral aspect of this economic system. But nevertheless, tobacco was an important component of it, and so it shaped history in a way. So tobacco, ever since it's been developed by Native Americans, has come in a variety of forms. And a variety of uses as well. So Native Americans traditionally, and Europeans eventually, would use tobacco medicinally. In sufficient dosages, it's a analgesic. It's a painkiller. So it can be used for aches and pains. It was also thought, rightly or wrongly, to cure a variety of things like colds and other ailments. Um, it was also used in religious ceremonies. So again, not used so much recreationally, but Native Americans did use tobacco in religious ceremonies. In sufficient quantities, nicotine can be hallucinogenic. And as we've already seen, and we'll get to in depth in a couple of weeks, hallucinogens are often involved in traditional religious ceremonies. They're often, the effects of hallucinogens are often interpreted as being spiritual experiences. So there are not just forms of tobacco use, but there are also forms of tobacco itself, and this determines the route of administration. So inhaling is obviously a very popular one. It's the most common way of using tobacco today, but that wasn't always the case. The other way is absorption orally. Not so much ingestion, not swallowing the tobacco, but holding in the mouth in one form or another. So the forms of tobacco are things like snuff, which is not as popular now, but a couple hundred years ago it was very popular. So snuff is powdered tobacco. So it is usually insufflated, that is, in this case, snorted, so that the tobacco and the nicotine are absorbed through the linings of the nose. That's the same way cocaine is absorbed. There's also chewing tobacco, which exists today, and is actually fairly popular, but it used to be more popular. So for centuries, chewing tobacco was actually was more popular than smoking, if not the most popular form of tobacco use. And chewing tobacco, I'm sure we've all seen, is usually taken as a small ball of tobacco that is then tucked between the cheek and the gum. And like the nose, the gums have blood vessels very close to the surface. And so it's very easy for nicotine and other other aspects of the composition of tobacco, other ingredients, to make their way across the gums and into the bloodstream. There were also cigars. So cigars were sort of a transition, they represented a transition between chewing tobacco and straight smoking tobacco. So smoking was actually not very popular in Europe, in European culture, until around the beginning of the 20th century. So for that period of time, chewing tobacco and snuff were more popular, and smoking didn't start to rise again. They'd been popular with the Native Americans, but smoking didn't become popular again till around 1910 or so. But cigars was that sort of transition because the cigar is held in the mouth and is often chewed, but can also be smoked. And so the nicotine, the tobacco, is used both ways in that sense. And then, of course, finally, cigarettes became very popular, and today are the most popular form of tobacco use. So cigarettes are smoked. They're not tobacco leaves like cigars are. They're not chewed because they're usually encased in paper and now often have a filter. So cigarettes are purely a smoking form of tobacco. But all of these things are vehicles for nicotine and the other ingredients to make their way into the bloodstream. And we've already talked about how substances are inhaled or ingested and how that affects the time course of drug activity. And we'll get into that again in a bit here. Okay, so those are the forms of tobacco. But the question is, how does tobacco get into the body, and how does nicotine have its effects once it's in the bloodstream? So we've already mentioned this, and most of us already know, that the primary psychoactive substance in tobacco is nicotine, which is this molecule shown here on the right. And it's named after Jean Nicot, who was a Frenchman. As you can see, the genus for tobacco, Nicotiana, is also named after him. These are all derived from his name. And nicotine is a direct acetylcholine agonist. So let's unpack that a little bit. We've used all these terms before, especially in our unit on the brain. But what does this mean? So it turns out that there are receptors in the brain, uh, and actually in the body also, that are for the neurotransmitter acetylcholine. Acetylcholine binds to them, and then that makes them active. There are ionotropic and metabotropic forms of this receptor that respond to acetylcholine, but there are a particular subclass of receptors called nicotinic receptors, and they're named that because nicotine affects these receptors. So these are ionotropic receptors, which remember are those receptors that let ions directly into the neuron, so they're very fast acting. So what does this direct acetylcholine agonist mean? Well, it means it's working on the receptors that use acetylcholine. In fact, it's working the acetylcholine system. It is an agonist, which means it enhances or mimics acetylcholine, as opposed to an antagonist, which shuts that neurotransmitter system down. So nicotine is an agonist. It increases the effectiveness, mimics acetylcholine, and it is direct, which means it binds directly to receptors, as opposed to affecting something like a reuptake, like cocaine does for norepinephrine, dopamine, serotonin. So cocaine is indirect, but nicotine is direct. It acts directly on the receptor and enhances the activity of acetylcholine. And what does acetylcholine do? Well, it has a couple of effects that are well known. First, it is the neurotransmitter that moves signal from your nerves into your muscles. So in order to move, your nerves transmit a signal to your muscles to contract, and acetylcholine is the transmitter that's used in that system. So acetylcholine is used for muscle contraction, but it's also used in the brain, particularly for memory. So there are a lot of acetylcholine neurons in areas like the hippocampus that are most involved in memory. And so the importance of that we'll get back to. But those are a couple of the effects of acetylcholine. There are others. Nicotine also has an indirect effect on the dopamine system. So it takes a couple of steps, but dopamine is released in greater quantities when nicotine is present. We're not going to go into the details, and in fact they weren't clear until somewhat recently. But dopamine is released, and it's thought that dopamine is the reason why nicotine is as reinforcing as it is. Again, we don't want to make the simplification of dopamine equals a reward, but dopamine is involved in reward processing. It's involved in learning. Those two processes are linked. And so nicotine affects the dopamine system as well, and so that's why it's thought that nicotine can be so addictive and so easily addictive. So dopamine is involved in learning and reward processing, and because of that, it's thought that that's what triggers that addiction. In terms of how quickly nicotine takes effect, it depends on the method of administration. So if it is smoked, as we know, inhaling a drug tends to make it act more quickly, and that's true here as well. If it's being absorbed orally, it takes longer, but it also stays in the body longer. If you're using chewing tobacco, there's actually more nicotine present in that form of the drug than if it's being smoked in cigarette form. So that's sort of the trade-off. You end up with about the same peak concentration of nicotine either way, but if it's smoked, it comes on quicker, goes away faster, and there needs to be less of it in the vehicle, in the cigarette. Chewing tobacco takes longer to kick in, it lasts longer, but there's also more of it in the chewing tobacco, and so you end up with about the same nicotine in your system either way. But nicotine, like so many other drugs, is eventually metabolized by the liver. And nicotine is also fast-acting, but also goes away pretty quickly. It's metabolized quickly. So usually after smoking a cigarette, the peak nicotine level occurs after about 10 minutes, but after that peak level is reached, it only takes about half an hour for the liver to metabolize the nicotine and for it to be flushed from the system, which is why people that to use tobacco tend to use it fairly frequently is because its effects don't last very long. So what are the effects of tobacco? So there are acute effects, and it depends on the dosage. And this is true of many drugs. But for example, epinephrine, also known as adrenaline, is released as a consequence of nicotine, of tobacco use. And so it is what's called a sympathomimetic. So it activates the sympathetic nervous system, which is why you get that sense of arousal. It also has analgesic effects, and this is one of the traditional medicinal uses. So you have lowered pain perception. You get an increase in alertness and attention, again, because it's activating the sympathetic nervous system through the release of epinephrine or adrenaline, just like a norepinephrine agonist like cocaine or amphetamine increases alertness, so does tobacco. There's a question as to whether nicotine actually enhances memory, and that's an area of current research because acetylcholine is involved in the memory system. It's unclear whether taking nicotine can enhance memory, and this will come up again in our second lecture. But again, it's not quite as clear as it is for things like analgesia or its effects on the attention system. But that there might be something there because of its involvement with the acetylcholine system. It may serve to enhance memory. So that's low doses, but of course high doses are possible also. And this carries with it some other acute effects. Things like nausea, things like dizziness. And these are high doses, but not as high as it can get. As we'll see, higher doses lead to more drastic effects. And these, nausea and dizziness, will be familiar to anyone who has smoked a cigarette for the first time or has worn a nicotine patch. Just basically anyone who's not used to a certain level of nicotine and suddenly that's introduced to the system. It's fairly easy to get sort of minimal nicotine poisoning without going to the full extent of having convulsions. So as I said, acetylcholine activates muscle contraction. So if you take too much of it, it's going to contract those muscles and you get convulsions. And of course, you take too much of it and eventually those convulsions, those contractions, can prevent the systems in your body for respiration and muscle contraction in the heart, and you can get death, which is obviously the worst possible side effect. But again, it takes relatively high doses in a very short amount of time because nicotine is cleared from the system so quickly. It takes a lot of nicotine to accomplish that. Technically, though, the lethal dose of nicotine is at approximately only 60 milligrams. And it turns out that's the amount of nicotine contained in a single cigarette or half a cigar. So a cigar contains 2 lethal doses, but it turns out you never really get all that nicotine in your system. And second of all, you're not absorbing it all at once. Cigarettes can be pretty fast, but a lot of the nicotine is not absorbed into the blood. It's in the smoke is inhaled, but then the smoke, of course, is exhaled as well. And that exhalation, that secondhand smoke, contains nicotine as well. Okay, and I'm sure we've all seen on smoking ads, or anti-smoking ads, that tobacco contains far more than just nicotine. And some of the things it contains are shown here in this picture on the right. But a lot of them are unpleasant. So for example, cigarettes contain tar, which is just a way of saying sort of a mixture of various hydrocarbons. Again, some of them are unpleasant, but tar is not a specific substance in and of itself. One thing that cigarette smoke contains is carbon monoxide. So often when organic compounds combust, when they're burned, they produce carbon dioxide, which of course we all exhale normally. And it's a substance we're all familiar with, carbon and 2 oxygen atoms. But there's also carbon monoxide, which is most famous for being in car exhaust. But it's the same substance, the same chemical. It's one carbon, one oxygen, and it has different properties than carbon dioxide does. For example, it has effects on hemoglobin, which is the molecule in your blood that carries oxygen. Carbon monoxide binds far more easily to hemoglobin than oxygen does. And so that's why it's a problem to be breathing car exhaust, is because carbon monoxide is displacing oxygen in your blood, and so you'll be short on oxygen. You'll have what's called hypoxia. And so it binds to hemoglobin more easily and also more strongly. It takes a while to clear carbon monoxide from your blood once it's been absorbed. And it's thought this is one of the main contributors to that shortness of breath that smokers often experience. Is they have carbon monoxide bound to their hemoglobin molecules, and they can't get enough oxygen. So there's not that much carbon monoxide in cigarette smoke, but because it binds so easily to hemoglobin, it doesn't take much to displace a lot of the oxygen in your bloodstream. There's also an element called polonium-210, which is a radioactive isotope of polonium. So radioactive compounds, generally something we should avoid ingesting. They can have carcinogenic effects. So radioactive substances, in this case the radioactivity is in the form of alpha radiation, which is not important for our purposes, but it's a form of radioactivity that doesn't usually affect us that much because it doesn't get past our skin. But once we ingest it, and once it gets into our lungs, then we can be in real trouble. There are also what are called nitrosamines, and these are carcinogens. And these are particularly an issue with chewing tobacco because they're right up there against the gum tissue, and it can lead to hardening of the gums and gum disease. There's also just good old-fashioned cyanide, which we all know is a poisonous substance, and it's poisonous because it interferes with the cellular machinery that produce ATP, which is the energy molecule. That's sort of our body's energy currency. So cyanide interferes with that process, and so it's not just oxygen absorption, it's also cellular respiration that's being interfered with. So there's a lot of pretty nasty chemicals in cigarette smoke, and that's an issue that we'll get to again when we talk about e-cigarettes, because e-cigarettes ideally are just nicotine delivery systems. So there's a controversy about whether that should be sort of a way of stepping down from cigarette smoking. So those are the acute effects, and those are the contents of tobacco smoke. And of course, a lot of those contents, it's not just nicotine, but tobacco smoking and tobacco use, not just smoking, but also oral absorption, is the cause of around 500,000 deaths every year. So a lot of this is from things like emphysema and lung cancer. And it was thought by a variety of people for centuries that tobacco might not be good for you, but we didn't really have any hard scientific evidence until the 1930s and 1940s, and that's when the connection between lung cancer and smoking really started to get established. That we had actual scientific evidence that it was bad for the lungs, as opposed to just suspicion for centuries. For centuries, of course, it was also thought that nicotine was medicinal. Some even hailed it as a wonder drug. So when scientific research got started on nicotine in the 30s and 40s, then we started to have an idea of how bad tobacco smoke could be for your respiratory system. And of course, smokeless tobacco, which is primarily chewing tobacco, carries with it some different problems, but problems nonetheless. And these are forms of cancer like oral cancer, throat cancer, esophageal cancer. And so obviously, your cancer risk for your whole body goes up, but the particular systems that are most affected are those systems that come into contact with tobacco, depending on your method of usage. For chewing tobacco, you also get things like gum and tooth disease. As we'll see, tobacco affects the cardiovascular system, and part of that effect is that those surface tissues really suffer because you lose those blood vessels near the surface of the skin, or in this case, the mouth. There are also these effects that occur in the cardiovascular system, and some affect the heart directly. So, because nicotine is a sympathomimetic substance, it activates the sympathetic nervous system. And one of those effects is an increase in heart rate and a constriction of the blood vessels. So what does that do? Well, it really raises the blood pressure. In addition to that, it also hardens blood vessels. So not unlike a high-fat diet will harden the arteries, the mechanism is a little bit different, but nevertheless, blood vessels become less flexible after nicotine use and after chronic tobacco use. So all of these things are obviously bad for the heart. This increases the risk of heart disease. Puts a lot of stress on the heart too, because you have lowered oxygen thanks to things like carbon monoxide, and you have high blood pressure. The heart's working really hard, but it's not getting all the oxygen it needs, and that puts stress on the heart and leads to eventually cardiovascular disease. So sort of less importantly, but noticeably, is it thins the skin, and that's why you see more wrinkled skin in tobacco users, because those blood vessels aren't nourishing the skin the way they should be. You have that skin becomes thinner. Can't support a thick skin on a weakened cardiovascular system, so you get more prominent wrinkles and thinner skin. And of course, it's not just the tobacco user themselves that is affected. There are things like secondhand smoke, which has been shown to increase cancer risk in anyone that's near the smoker. And of course, this has to be a chronic presence. It's not just walking by someone on the street who's smoking. But if you're in a household of a smoker, your cancer risk is increased. Not as much as the smokers, but still, it's been proven that the secondhand smoke has a negative effect on health. There's also what's called side stream smoke, which is distinguished from secondhand smoke. Secondhand smoke is smoke that's exhaled by a smoker. So they've already inhaled the smoke and absorbed the nicotine, or some of it, and a lot of the carcinogens. But there's still some present in that secondhand smoke. Side stream smoke is the smoke that is coming off a cigarette when it's not being inhaled. So when someone's not taking a drag, as it's called, that cigarette is still burning. And so that side stream smoke is actually higher in carcinogens than secondhand smoke is, because the smoker has already absorbed some of the carcinogens for you, but the side stream smoke, it's just being released into the air. And of course, there are well-known prenatal and postnatal effects. So these are effects on unborn children and children that have been born. So for example, smoking doesn't seem to shorten the gestation period the way it does for the way other drugs seem to, but it does increase the risk of miscarriage. It also tends to reduce the birth weight of the child. And again, it's not shortening the gestational period, so it's not just that the baby is born at an earlier stage, and so it's smaller. It actually does seem to lower the baby's birth weight, even for the same amount of gestation. It also seems to increase the risk of sudden infant death syndrome, or SIDS. It's not clear whether it's the prenatal exposure to nicotine or being exposed to smoke after birth, but it is clear the connection between SIDS and smoking at some stage is fairly clear. You also tend to get a higher incidence of developmental deficits. So things like attention deficit, also delayed language ability, delayed mathematical ability. These are all consequences of smoking by a pregnant mother. There also seems to be a correlation between paternal smoking and childhood cancer. And this seems to be prenatal. And so what seems to be going on there is that some of the chemicals in tobacco smoke are affecting sperm production. So you get more copying mistakes in the DNA. And so you have these children whose father smoked prior to conception. These are usually chronic smokers, and that leads to a higher incidence of childhood cancer. And so it's thought that tobacco smoke has degraded the quality of the DNA in those sperm. So it's not just a maternal effect. You have both parents smoking can contribute to the health of the child. Also, there's an increased chance of dependence, especially for adolescent smokers who were exposed to tobacco prenatally. So if the mom smokes, that child is more likely to become dependent on tobacco. Not more likely to use tobacco necessarily, but if they do start using tobacco, they are at a higher risk for dependence. And of course, it's not clear whether these are more environmental effects or whether these are genetic effects or whether these are developmental effects. Because the child is gestated by the mother and the mother is exposing the child to tobacco, to nicotine in particular, obviously the child has the mother's genes, but is developing in a nicotine-heavy environment, and is also probably growing up in that environment. So it's hard to tease these things apart. So the best thing is just to play it safe and not smoke at all during pregnancy, and not to be around cigarette smoke during pregnancy. Okay, so that is it for today. That is our coverage of the history of tobacco and the effects of tobacco. Next time, we'll continue to look at tobacco, and really we'll look at a more social level. What has society's response been to tobacco, especially in terms of regulation? Also, what are the demographic trends? Who smokes? Who's likely to smoke? Why do they start smoking? What form of tobacco are they using? And dependence. Why is it so easy to become dependent upon nicotine? And once dependent, what can you do? So that will all be discussed next time, and I will see you then.